Okay, student, let's see this question that came in NEET 2025 physics. It is related to thermal conductivity or thermal properties of matter. What I have been given here is a temperature difference and a composite rod with different thermal conductivity. Although the rods are identical as given in the question, that means their length, area will be same, only the thermal conductivity is different. Now, how do you see this question is important to solve this? You should see it like, there is a potential difference and these are series resistances and same current will flow through all of them. What I mean by current is the heat current, right? So let's find out, let's equate the heat current across all the junction and you remember this, right? The heat current delta Q by delta T, the heat current or dQ by dt is given by Ka by L into temperature difference, right? This formula we will use. So let's write it down, the heat current. So the heat current flowing through this resistor is equal to heat current flowing through this resistor equal to heat current flowing through this resistor as well, and it is equal to the heat current flowing between 3T and T, all are equal. So this will give you enough equation to solve this problem. So let's write down that equation. Heat current dq by dt is equal to, here you will write 2k into A by L into difference of temperature between this resistance, which is 3T minus T1. This should also be equal to, the thermal, this you write K A upon L, thermal conductivity in the second one is this K only, right? So then multiplied by the temperature difference here, which is T1 minus T2. And then that should also be equal to the temperature difference across this junction, which is T2. Wait a second, we'll write here, thermal conductivity 2K into A by L, Ka by L equivalent term, multiplied by the temperature difference here, which is T2 minus T. Not only this, it is also equal to the heat current that will flow from between 3T to T across all these resistance. They are all in series. So let's write down that as well. So this also will be equal to, you write down total resistance, total temperature difference is how much? 3T minus T, and total thermal resistance value is L by Ka, just inverse of this term. So you write down all three are like thermal resistance. So you will write, okay, this will become L by 2Ka for this one. Then the second one, it will be L by Ka, and the third one will be L upon 2Ka, right? Now let us see how can we simplify and get just the ratio. Okay, so we just want the ratio. Okay, right. So let's little simplify this thing, that how it will come. So if you see, it will be half plus 1 plus half. So half plus half 1 plus 1 2. So you'll get here 2t 3t minus t divided by half plus half 1 plus 1 2. So 2L by Ka. Okay. So this 2 get cancelled. Then you can write it as, okay, it is Ka by L into T, right? Now you want ratio. You want ratio of T1 by T2. So your target, one way to solve would be to find out T1 and T2 and divide. That also you can do from these equations. So let us equate what will happen. So if you see all this term, when you are equating this Ka by L, you can cancel. Ka by L you can cancel. Equal, right? Here also we got Ka by L cancelled. So what we get? The formula will simplify a little bit. So it will become 2 into 3T minus T1 is equal to T1 minus T2 is equal to 2 times T2 minus T, and it is also equal to here T. Okay, now it is very much simplified. Then choose any of the equations to solve for T1 and T2. Okay, if you can find the ratio directly, it's fine. Otherwise, you see, if I equate this one if I equate this one with this, I'll get the value of T1, right? So let's see. Let's calculate it mentally. It will be 60 minus T1 is T. 60 minus 2T1, right? 2 is equal to T. That's my equation. I'll get T1 from here. What is T1 equal to? So we'll get 60 minus T divided by 2. So we'll get 5T by 2. Okay, that's fine. Then similarly, in order to solve for T2, you can solve these two equations. Okay, let us see what this will be equal to. So we'll get 2T2 minus 2T is equal to T. So what is T2? T2 will become 2T goes that side, 3T divided by 2. So 3T by 2. Now you got T1 and T2. So can you find the ratio? You can see here T1 by T2. Everything else is common. It will come as 5 by 3. So that's why our answer will become 5 by 3. Cross check. T1 is higher, T2 is lower, right? So 5 by 3, right? All right. So that's how you solve this problem. So the question is related to thermal resistance and heat current. We'll see you in the next question. Thank you.